This is R.D. Sharma solution, class 12, chapter 19, exercises 19.8. Indefinite integrals. We are taking question and answer on that. Now this one, e raised 3x by e raised 3x plus 1. We know that the differentiation integration of e raised x is e raised x only. Now what do we do is, the trick is we always take the denominator and we take it as t differentiated and try to get the numerator out of it. For example, if you take t as e raised 3x plus 1, which is the denominator here, when you differentiate it dt by dx, what are you going to get? E raised 3x will be e raised 3x only. And differentiation of plus 1 will be 0. And differentiation of 3x also has to be done, and that 3 has to be written. So dt becomes 3 into e raised 3x dx. Now in the numerator you see e raised 3x into dx. So e raised 3x into dx can be written as dt by 3. So the numerator now in terms of t becomes what? Dt by 3. So dt will write it here. 1 by 3 will take it outside the integral sign. And this denominator of course was t. So keep it as t. Now how easy it is now. Log, that is log base e, ln we write. Modulus of t plus constant of integration. 1 by 3 will be there outside. Now this t was actually e raised 3x plus 1, which we let or supposed in the earlier period of time when we started this question. So 1 by 3 ln e raised 3x plus 1 plus constant of integration. This is your final result or answer. So this is how you're going to go about it. Whatever we have explained right there. Okay, 3 sec x plus 5 in the denominator. In numerator we have sec x tan x. And we know that the differentiation of sec x is sec x tan x. So you can see that how the things unfold. Sec x, if you put it as t, I'll show you one more question where it's not necessary to put 3x, this sec x equal to t. You can have 3 sec x plus 5 also. You'll just see in a later question. Right now sec x equals to t, dt by dx is sec x tan x. So dt will become sec x tan x into dx. What do you see here? This is nothing but the numerator. What do you see here? Numerator, denominator was 3t plus 5. So it's a form of ax plus b integration. And you know already what is the differentiation of that. So let me write sec x tan x dx as dt. The denominator is 3 sec x plus 5. For that we have 3t plus 5. So just imagine that this is dx by 3x plus 5. So we have a direct result out of it. So 1 by 3x plus 1. If you assume it like this, 3x plus 5, sorry. So the result will remain the same, ax plus b. So this will be ln 3t plus 5 plus 5. Don't stop here, because 3t plus 5 has to be differentiated. And whatever the result is has to be divided. So 3t plus 5 d by dt, just do d by dt out of it. So when we do this d by dt or differentiation with respect to t, this is going to be 3. So this 3 has to be divided. So 1 by 3. What was t earlier? It was sec x. So it will be 3 in place of t, just write sec x plus 5 and then the constant of integration. So t is sec x here. This is your solution. So this is what we were talking about. So you can take 3x, see 3 sec x plus 5 equals to t also. We'll just see in one of the questions coming up. If you remember, this cot x minus 1, cot x plus 1, 1 minus tan x, 1 plus tan x, cos x minus sin x by cos x plus sin x, sin x minus cos x by sin x plus cos x. All of them have the same way of proceeding with the solution. Exactly similar. One of the questions we have earlier tried, and we tried to give you another answer, a different approach. But the basic approach remains the same here, which you see here. And you will recall, once I will come to that point, you will recall. I am sure about this. Cot x can be written as cos x by sin x. So 1 minus cos x by sin x. Denominator becomes 1 plus cos x by sin x. Okay. So just take the denominator or the LCM and sin x. So sin x goes here. Cos x goes here. Sin x remain in the denominator. Now coming to the denominator, actual denominator, sin x plus cos x divided by sin x. So this sin x gets cancelled. So you have sin x minus cos x divided by sin x plus cos x. Okay. Can you decipher something? Decipher, I should say. See, this sin x plus cos x, if you put it as a t, this dt by dx will give you sin x will be cos x will be minus sin x. Alright? Sin x is cos x is minus sin x. But you have sin x minus cos x in the numerator. So you ought to get this sin x minus cos x from there. So let us take a negative outside from here. So you can make it as sin x minus cos x with a negative sign outside. Dt by dx is here. Now this negative goes on one side and dx goes here. That is, negative dt is nothing but sin x minus cos x dx. So if you just remove these, just consider the top sin x minus cos x and the bottom sin x plus cos x. So what do you get here? See, sin x minus cos x into dx is minus dt. We just found out that thing. Sin x plus cos x we originally kept as t. So what is the integration? Integration is simply ln modulus of t. Negative will remain there. If you can take this negative inside and do something, simplification you can do, then it's okay. Otherwise just keep negative outside. It's not a big deal. So we have t here, and remember what was t? T is sin x plus cos x. So you have a negative outside, then we have a ln sin x plus cos x, and then the constant of integration. This is what you see is the correct answer. So this is the solution I was talking about. What do you see here? Same thing. The different questions which I just spoke when I started this question, all of them are solved in the same way. Sec x cos x log tan x dx. Please remember this log 10x or log x. This log is base e. So I am writing log, but basically ln is log base e. But we can change, we can use this interchangeably. So what do we have? T equals to log tan x, the denominator. Normally we keep it as t. Dt by dx will be log tan x is 1 by tan x. Tan x will be sec square x. Okay. Sec square x, see, it will be 1 by cos square x. This sin x cos x, sin x will remain here. Cos goes up. 1 by 1 cos gets cancelled. So you have 1 by cos x by sin x. So it will go up. And when it goes up, you are going to get this sec x cosec x. That's what we wanted, right? So this goes up, cos goes up, becomes sec x. This sin x goes up, it forms cosec x. And sec x cosec x into dx is what we wanted, and this has become dt. So the numerator, you can just keep it as dt. So this is the integration, dt divided by this is whole is t, and this is a d. You don't have to write anything, dt is already there. So this will be ln or log, because we have initially said that's ln only, log base e. The log base e, when take the modulus, and this is log of 10x. And then you have this, because it was originally t, which we imagined. This is your answer. So the direct answer, see, I just, removed one step, which is dt by t is log modulus t plus c. Then we go to that answer. So this is what we were talking about, right? Next one is 1 by x into 3 plus log x dx. So this log x differentiation is 1 by x. You already know that. So 1 by x dx you will directly get from here. But how about keeping 3 plus log x as t? That can also be done. T equals to log x or t equals to 3 plus log x. It's up to you. Both can be taken as t. When you differentiate dt by dx, it will be 1 by x. So this dt will become dx by x. So dx by x is already there. So just keep or put this dt here. So this is integration of dx by x is dt, 3 plus log x, 3 plus t. If you would have done 3 plus log x also as t, same thing you have got. Okay. So dt by 3 plus t, this is a form of say 1 by x plus b. A is 1, b is 3 here. So log 3 plus t plus constant of integration. So you have log here in place of 3 plus t, you can replace it by log x plus constant of integration. So only 2 steps we have used. See, this was so easy. The only thing is, if you know the trick that 3 plus log x gives you dx by x, that solves the issue. This is the result we were talking about. So you just have to follow this. Now see here. You see, if you take 3 e raise x plus x equals to t. If you take t equals to e raise x plus x, directly the numerator will come. So dt by dx will be e raise x will be e raise x only, and this x will be 1. So this is what we wanted. So dt will be e raise x plus 1 into dx. Now this you can just replace it by dt. So numerator becomes a dt here The denominator is e raised x plus x, which is t, and the result will be log modulus of t plus c, ln basically, log of t plus c. It will be ln, what will be t? This t you kept or assumed it to be e raised x plus x, so just replace it by e raised x plus c. This is your answer. So what is the result? This is your result. Okay. Now this is quite straightforward for you. Log x gives you directly 1 by x. So just take log x as t. Dx by x will automatically come. So I'm now equating t as log x. Dt by dx will be log x will be 1 by x. Dx you can take it on the right hand side. So dt will become dx by x. So this one which I'm pointing out, making a region, and that region is simply dt. So you have a dt here, t in the denominator. Log x we took it as t. It will be directly log base e modulus of t plus constant of integration. They follow the same routine which we have done for the previous 3-4 questions. So log modulus of t plus constant of integration. T replaced by log x because you have introduced it by yourself. So log x, log x, but it has to be inside the modulus plus constant of integration. So this is how it will be made. So just write this here, putting all this you have to write by yourself. All the symbols, make it proper, right? Now sin 2x divided by a cos square x plus b sin square x. So let's divide and conquer. We know that this sin 2x is 2 sin x cos x. We'll try to get this 2 sin x cos x or at least sin x cos x per se. So let me write it in order to actually let you know that sin 2x is 2 sin x cos x, which is known to you. And even if we get sin x cos x, that will solve our purpose, because we now need 2 sin x cos x dx in the numerator, or sin 2x into dx in the numerator. But putting what? Placing what? If you see this sin square x, if you differentiate it, it will be 2 sin x, then sin x will be cos x. So if you put this sin square x as t, you are going to get this. So I'm replacing cos square x by 1 minus sin square x here. And this sin square x will be same. So wherever we have cos square x, I'm replacing it by sin square x. So this sin 2x in the numerator, a into a minus a sin square x plus b sin square x. So just keep those sin square x terms together and other terms separately. That is, if you multiply this inside, I'm talking about the denominator, to be a minus a sin square x plus b sin square x. So I'm taking this b and negative a with sin square x together. A is a separate constant, so I'm keeping it separately. Now let us take sin square x as t. You see what will happen. dt by dx will be 2 will comes front sin x, then differentiation of sin x will be cos x. So dt will be 2 sin x cos x dx, which is basically sin 2x dx only. So this sin 2x is nothing but 2 sin x cos x. This whole is already dt. So 2 sin x cos x, you can just write it like this. b minus a sin square x plus a. I'm trying to show you that this sin 2x is nothing but 2 sin x cos x, which we have retrieved from putting t as sin square x. So this is dt by b minus a. Sin square x is t. It's not t squared, it's t plus a. Okay, now again, simply the same discussion. dt by or dx by 1 by dx by ax plus b. Let me write it. Integration of 1 by ax plus b dx is simply 1 by a log base e modulus of ax plus b. This we have already done in several questions. I'm just trying to make it formal now. So this 1 by a, what is a here? B minus a. Just follow this one, okay? That was right one, was just the formula, but we have to follow this. ln b minus a into t, because this is plus a plus constant of integration. Now just one thing you have to do. T was sin square x, just replace t by sin square x. And that will formulate your final result. So 1 by b minus a, this is ln, and you take the modulus b minus a into t will be sin square x plus a, which is constant of, constant of integration has to be put in the end. One more thing you can do. See, 1 by b minus a was already there. Now b minus a into sin square x plus a. So b sin square x minus a sin square x plus a. Now how we combine this a and a? That will be better. We can keep it like this, but just for the sake of completion, it will be b sine square x, and you take just a common from here. When you take common here, it will be 1 minus sine square x. 1 minus sine square x is cos square x only. So what do you see here? The denominator has come already. This is the denominator of the actual question, which has come in the ln. So this is the way you are going to go about it, and practice will make you more comfortable when you solve this question in the later part when you have actually exams of yourself. So this is how it goes. Now cos x by 2 plus 3 sin x. So this we can directly deal. I told you I'll come up with a question where I'm not going to write just sin x as t. I am going to put 2 plus 3 sin x equals to t. You'll see the same result will come. I told you earlier also that it's up to you which makes your life comfortable. So rather than having just sin x equals to t, just put t equals to whole of the denominator, which is 2 plus 3 sin x. Now differentiate it. dt by dx will be 3 cos x. So this cos x into dx is what? Now multiply this. dt will be equal to cos x into dx, and this 3 will come in the denominator. So wherever you have cos x into dx, just write dt by 3. 1 by 3 you can take just outside the symbol of the integration, and dt divided by t. Now you know the standard result, which you have been doing for almost 20 questions now. So this will be 1 by 3 ln modulus of t. So what was t? You have to replace it by 2 plus 3 sin x just now. So 1 by 3 ln 2 plus 3 sin x, and then the constant of integration. This is your final result. Now knowing it and solving it are two separate things. I told you how to do it, but this is how you are going to actually write it, right? If you take sin x equals to t, this is the result. I took 2 plus 3 sin x as t. So the result remains the same, alright? There may be different paths, but the manzil is same. The result is same. This question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.